Welcome to NASA Launchpad. I'm your host, Audrey Staples. So, what's one of the main reasons that NASA researchers are so excited these days? Well, we're talking about water. Sure, water is a big part of life here on Earth, a huge part actually, but it's not as common on other bodies throughout our solar system. So, whether we're talking about the water ice that the Mars Phoenix lander discovered, or, more recently, the water ice kicked up by L-Cross on the moon, now's a good time to start thinking about what we can use that water ice for. What would I do with it? Start packing it up and flinging some Martian and lunar snowballs, but I've been told I can't make a snowball on Mars, or on the moon for that matter, or anywhere else we know of except Earth. But why not? Well, let's ignore the fact that I'm not an astronaut, so I won't be leaving Earth anytime soon. There are two main reasons why snowballs can only be made on Earth: phase changes and the unique properties of water. So let's explore these reasons a bit further. And for that, let's talk to Dr. Peter Wasilewski of NASA Goddard Space Flight Center.
Life on Earth in all its seasons is, about the phase diagram of water. If you go from one form to another, you exchange energy. You give up energy, you take in energy to move from one state to another. The unique thing about water is, for example, if you make a solid, the solid floats. Can't think of anything else that has those conditions.
And we know how important floating ice is to life here on Earth. Water actually becomes less dense as it freezes. How can that happen? As water freezes, the hydrogen bonds in the water molecules form crystals, and the molecules actually spread out a bit. As a result, a block of ice is less dense. It is lighter in weight than the same volume of liquid water. Without this unique property of water, the ice that forms on the top of a pond or lake would sink to the bottom, and the entire lake would eventually freeze. Instead, ice forms a layer on the top of the lake that actually serves as insulation to protect the fish and other water animals from freezing. Right, so what does adding or removing energy, or ice floating, have to do with a snowball? Well, first, we need to look at a phase diagram like this. Basically, what a phase diagram shows you is what phase of matter a substance would be under certain conditions of pressure and temperature.
Anything that has water in it, you can more or less describe within that phase diagram as you move from an ice to a water to a vapor. You're exchanging energy, driving. You have to either lose energy or gain energy as you move back and forth.
So when you add or remove energy, that leads to changes in temperature. You probably know that when you change temperature, you can change the phases of matter. Here's an easy example. When you boil liquid water, it gets hot, and once it reaches 100 degrees Celsius, it phase changes to a gas or vapor. But you probably didn't know that you can also change a substance's state of matter by changing the pressure exerted on the substance. As pressure increases, the molecules in a substance are pushed closer together. And in most substances, when they're squeezed hard enough, they're compressed into solids, but not water. In its liquid state, water molecules are actually closer together than in the solid state. So that means you can apply pressure to ice and it will actually turn to liquid. You can check this out pretty easily. You just need a piece of string, ice, and two weights to tie to the string. And no, you don't need salt. It isn't that kind of demonstration. Just tie the weights to the ends of the string, hang the string on the ice, and wait. You might have to wait a long time, but eventually, the pressure of the string will cause the ice to change phases into liquid, allowing the string to slowly cut through it. Now, because the rest of the ice is still frozen, the liquid will refreeze over the string. Cool, right? So really, how's water different from other substances? Take a look at this. On the right is a phase diagram for carbon dioxide, which acts like most substances. On the left is a phase diagram for water. Look at the lines dividing the liquid phases from the respective solid phases. In the water, if the temperature is decreased below 0 degrees Celsius, but the pressure is high, like in this region, water can still be in liquid state. But in the carbon dioxide, like most other substances, increased pressure will actually make it more likely for the substance to be in a solid state. Something else to take into account: liquid water is more dense than solid water. That's why ice cubes float. And that also plays a key role in making a snowball. To make a snowball, you have to compact the snow, which temporarily increases the pressure. This causes some of the snow to melt. When you stop pressing, the water refreezes, and that's what holds the snowball together. Pretty simple. Water, pressure, and snowballs. Oh, and temperature. Did I mention temperature? If it's more than a few degrees below freezing, you cannot squeeze hard enough to create enough pressure with your hands to change the snow into a liquid and make that snowball. In fact, at the South Pole, at temperatures around -25 degrees Celsius, that's -13 degrees Fahrenheit, you'll need about the same amount of pressure to make a snowball as you would need to crush a submarine. Now, you know why there aren't any snowball battles in Antarctica. Even though Mars is the next warmest place in the solar system, with enough water ice to think about snowballs, there's no way you can make snowballs there. During winter, a low temperature at the poles is about -125 degrees Celsius, or -195 degrees Fahrenheit. The average temperature on Mars is about -60 degrees Celsius. That's -80 degrees Fahrenheit. No Martian snowball battles. Sorry. And you just can't make snowballs on Mars, or the Moon, or any other place. At least that we know of right now. Besides, NASA's got more important goals for the use of water ice on other heavenly bodies. For example, in situ resource utilization, using materials found where you're going rather than bringing everything with you. And hey, maybe the Kepler mission will find another planet where it's possible to make snowballs, and my dreams of another worldly snowball won't just have a snowball's chance in Mars. That's it for now. I'm Audrey Staples, signing off for NASA Launchpad. Thanks for watching.